Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on brown cows, an introduction to the binomial distribution. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. In this PowerPoint, we will introduce the binomial distribution and show how the formula for the binomial distribution works. Mrs. Borlaug uses the formula to calculate the binomial problems and only uses the calculator for the multiplication of the values in the formula and adding probabilities together. She does not use the binomial probability distribution command that is found on the TI-83 and 84 calculators. Since she uses the formula, so will I in this video. Before we start, we need to do a quick review of an arithmetic fact. Which of these is true? 6 plus 6 plus 6 plus 6 plus 6 equals 6 to the 5th or 5 times 6. 6 to the 5th actually means 6 times 6 times 6 times 6 times 6, and multiplying 6 5 times is not the same as adding 6 5 times. So that is not equivalent, and 6 added 5 times is the same as saying 5 times 6. Remember, a quick way to add up the same number is multiply the number by how many times it's added together. 1, 2, 3, 4, 5 times 6. We will illustrate how binomials work by starting with a problem about brown cows. All the cows in a herd are brown. The probability of getting a brown calf when one of the cows is bred with a certain bull is 0.90. If 5 cows are bred to the bull, find the probabilities of getting X brown calves. Let B equal a brown calf and N equal not a brown calf, because math teachers love their notation and hate writing out the words. So our scenario has us looking at 5 cows or calves at a time. We want to look at the possibility first of having no brown calves. That would be N for not brown, N, 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 or 5 N's. What is the probability of that happening? Or better yet, how do we figure out this individual excuse me. How do we figure out this individual probability? Well, the probability of the first cow not being brown is 0.1. The probability of the second cow not being brown is 0.1. The probability of the third cow not being brown is 0.1. The fourth cow, 0.1. The fifth cow, 0.1. And if I multiply that together, I will get 0.00001. How many ways have I done this? How many options do I have? Well, I have one option of having no brown calves. We want to figure out a way to do this as we expand our problems into different types. So how many ways out of the 5 that we're looking at are there places to pick, no places to put the bee or the brown calf? Well, that would be a combination, and that would be 5C0 because the order of the bees do not matter. And as we look at this last column, or the total probability of no brown calves, we can see that the total is 0.00001, which is one of the 0.0001s, and that's the total of those. And we get the 1 by thinking of it as 5 combination, or 5 choose 0 times 0.1 raised to the 5th power. And a pattern will begin to emerge here, but it has not started to emerge yet. Moving forward, our next step is in our set is to look at having one brown calf. So for one brown calf, we have 5 possible scenarios, and you can see those on the screen. I'm not going to read those out loud. And the individual probabilities could be 0.9 times 0.1 times 0.1 times 0.1 times 0.1, 0.1 times 0.9 times 0.1 times 0.1 times 0.1, and you can see how that matches up to the letters. If the third cow is the brown one, then the 0.9 goes in the third spot. If the fourth cow is the brown one, then the 0.9 goes in the fourth spot. If the fifth cow is the brown one, then the 0.9 goes in the fifth spot. If you need to, take a minute to stop and look at that and see how we're getting the individual probabilities. The probability of being brown is 0.9. The probability of being not brown is 0.1. So you should see where all those probabilities are coming from. Notice that these will all equal the same thing. The order at which we multiply does not matter, and when we multiply them together, we will get 0.00009. I think I said that right. It should be 0.00009. So I'll go back to how it was written before. How many ways do we have? Well, we can count and see 5, but think about it this way. How many ways out of the 5 places are there to pick one place to put the bee? And the order in which we pick the bees is not important. That would be 5 combination 1, or 5C1. That gives us 5. And again, if I added up those numbers, that would be 5 sets of 0.00009, which gives us 0.00045. And working backwards here, that's 5 times, how many 0.9s did we have? Well, in each problem we have 1.9 and 4 0.1s, and the 5 comes from 5C1 times the 0.9 to the first power times 0.1 to the fourth power. And even though I don't like stopping in the middle of a problem, we're reaching around the 9.5 minute mark, and I don't want to go over or split in the middle of one of these screens. So I'm going to pause the video here, and you definitely will need to watch part 2 to conclude this example. Thank you for watching.